Hello everyone, I'm Sebastian Y, and this is Principles of Microeconomics. In this video, I'm going to solve this exercise on game theory. As always, I highly recommend you attempt the exercise first, and then watch the video. Here we have a simple price setting game where we have two firms who are competing with each other. They can charge either $5 or $10. We're going to assume that if they both pick the same price, they split the demand equally, and if one price is under the other, they take the entire market. We're given a little information about the demand function that tells us at a price of 5, we have a quantity demanded of 300, and at a price of 10, a quantity demanded of 200. We can use this information to draw up our game matrix. Since we have two players and two strategies, we're going to have our classic 2x2 game matrix. So I'm going to draw a box and then divide it up into 4 quadrants. Our two players are Pizza House and Papa Jim's. It doesn't matter which one you put on the columns and the rows, just as long as you are consistent about it as you go through. We have two possible strategies here. They can price at 5 and they can price at 10. Those options are the same for each player. Next, we need to think about the profit that they're going to make. The problem stated that we're going to assume for simplicity that there are 0 costs, so we're just going to calculate the revenue for everyone. If both price at 5, they're going to split the total quantity demanded of 300 in half, so that's 150 each. So if we're at 5 and 5, the profits are going to be 5 times 150 for each of them, and that's 750. So Pizza House is going to get 750, Papa Jim is going to get 750 as well. I always write the payoffs lower left for the player on the rows, upper right for the player on the columns. Next, if they are both pricing at 10, then they're going to split the quantity demanded of 200 in half, and so that's going to be 10 times 100, which is 1,000. I'll write those in as well. Now we need to see what happens when one of the pizzerias undercuts the other. So 5 and 10 or 10 and 5. In this case, the player who chose $10 is going to sell nothing. So in the upper right, that's Papa Jim's. They're going to get nothing, and Pizza House is going to get the entire demand of 300. So that's going to be 5 times 300, which is 1,500. If we look at the lower left, this time Papa Jim's is doing the undercutting. They're going to get 1,500. Pizza House gets nothing. That's our game matrix. Remember that we need to have our 3 components of a game: players, strategies, and payoffs. Next, we're going to figure out our Nash equilibrium. The way this game is set up, we have a classic prisoner's dilemma situation. Notice that for Pizza House, picking $5 is always better no matter what. If Papa Jim's picks $5, then Pizza House is better off picking 5 because 750 is better than 0. Had Papa Jim's picked $10, Pizza House also prefers $5 because 1,500 is better than 1,000. And so Pizza House is always going to pick $5, and since the game is symmetric, Papa Jim's is also going to pick $5. So our Nash equilibrium is both firms picking $5, and each firm is going to make a profit of $750 each. The final question asks us, if they were able to cooperate, how much profit could they make? We can go back up to the game matrix and see, in our Nash equilibrium, we're going to end up at 750 and 750 profit, but there is a situation over here where both firms are making more profit, 1,000 each, had they been able to cooperate and both agree to price at $10. Of course, that doesn't hold up in the Nash equilibrium because the self-interested strategy is always going to lead them to pricing at 5. But had they been able to cooperate, they could have made 1,000 each. That's all there is to it. If you have any questions, feel free to let me know. Thanks for watching.